in 5 days. So let's see so how we can manipulate this and how we can write a for loop. So in order to know how we can do. So let's say I want to have the precipitation for the past 40 years. So I'm creating a variable called years. So I'm also making a list of sequences so that I want to start my year from 1981 or 2 to let's say 2020, and that's it. So I don't want the steps, I want all my 40 years to be in. So now if we can just print years, click on the run, you will get a list of sequence with the 40 elements. We have the years for which I want my rainfall dataset to be. So this is helpful while you write a function and you map it over. So I have 40 elements with all steps in. So if you want to see the documentary on list.sequence, so you can always go to the documentary, and if you can just open, so it will generate a list of numbers starting from the start number as well as the end number. So you can specify the steps in it, so like what is should be the gap between each of the sequence, and you can also specify the count. So if you do not provide any of the steps, so like for example now I have don't provided any of the step. If I provide my step or the interval between the years to be, let's say, 5 year, so now if you click on run, I have only this much of elements from 1981 to 1986, like that we have. So similarly you can also specify the counts if you want. So as of now I want all my 40 elements to be in here, so just click on the run. So I have my 40 elements with 40 years in it. So next let's just create one more variable, and we can map it over. So I want my start date to be, let's say, let's create a variable called or let's create a function called yearly precipitation, or simply yearly ppt you can use for short. And I'm writing a function which will take input of my list in the sequence. So for example, let me call it a year, and it should return the total precipitation out of it. So now I want to filter my chips dataset. So you create a variable or you create a variable called start date. So I want my start date to be in the time range or ee dot date. So this is a earth engine function to create the date. So ee dot date from year, month and date. So this will return a given date, year and a month of a day. So you just have to specify which year you want. So I want the year which I have given from my sequence to be in my function, and I want from the month January, and one is the date the 1st January 1981. So we are starting from 1981 and we will end at 2020. For the past 40 years, we will plot the precipitation trend line for the 40 years. So now I have my start date. So I want my end date also. So you just create one more variable called end date. So it should be 1 year more than my start date. So because when I filter my chips data set, so it will be exclusive date when the end date is given. So I want my start date and advance by 1 year. You have to specify what is the unit of your advance. So again you go to documentary, and here you search dot advance. So here you will find one element, e dot element dot advance. So you have to specify a delta number which I specified to be 1, and you have to specify the unit also, like I have specified in here for year. So I want my end date to be 1 year advance than my start date. So this is how the function works. So you can also specify the time zone if you want to be more specific than it. So my date ranges are ready. So now I want to create a variable called total precipitation. So I will filter my chips dataset to bounds. So remember, I have created one point geometry that will be my boundary. That is will be in my region of interest. So I have filtered it down to my region of interest. Now I want to filter it down to date. So with the use of the function ee.filter date, so it would start from my start date and end on the end date. Remember, my end date is 1 year advanced than that of my start date. So my filtering is done. So I want the sum of all of it, because since it's a precipitation data set, I'm plotting the total precipitation out of it. I'm not taking the mean here, I'm taking the sum. So it will add all the rainfall which has happened for the region of Karnataka, which I have specified in here in the point. So it will get the sum of all the rainfall that has happened during that period of time. So we'll see the graph, we'll see the trend line. So please stay tuned till the end of video. So we have the sum now, we have filtered it down, and done. My total precipitation is done. So I want to close the function. It should return my total precipitation. Yeah, now my function is ready. So you can now map it over your list of sequence which have the years. We have created a variable called years. So we will map this function over these years in order to get the precipitation over 40 years, past 40 years. So create a variable called so all precipitation. Maybe you want you can name the variable anything, just remember it will be easy for you. So I'm creating a variable called all precipitation. So for my years, which is a list, I'm mapping a function. The function name is yearly ppt. So now we have mapped our function for all the years in the sequence. So let's print it down in order to know is it worked or not. So we have two lists. One is for the year, second is for the image. So you see we have the 40 elements, 40 images. So each for one of the bands. So each for 1 year, we have the precipitation band in here. So but you can see the problem in there is we don't have the timestamp for it. So we don't know the image 0 or the image 1 is of which year. So we have lost some of the properties from the main chips data set, so which we want to settle it now. So if you know, we have written the list of sequences. So if you print it down here, you will see it's a list. So I want it to be image collection. So or I want to add some of the properties. So how can I do it? So there is a function called dot set. So with this I can set the properties for my images. So I want to set my, let's say, system start date is equal to, so let's say my system that is the start date, and I also want my system end date. That's it. So yeah, I have set my property to be there in my all the images. So let's give it a run. So now you find I have the images, I have the bands, I have my data type. So here you find that we all have our system end date, we have our system start date, and we also have our year. So this is the function called millis, which will convert the dates into a format where the Earth Engine uses it. So you can search dot millis in here. So here you find the number of milliseconds since 1970. So in this format only, the Earth Engine will decode the date ranges. So it's always helpful if you convert your dates from date normal date format to the millis format. So it will be in the milliseconds since 1970 for this date. So this is how the Earth Engine will interpret your data. So now we have our 40 elements with the properties in. So we have the images, we have the years, we have the start date and the end date. So this is what are required in order to plot my graph now. So let's just create a variable called chart, and also you create the function ui.chart dot image by series. So this is the same function which we have used in our last tutorial. So we need to specify the image collection. The image collection will be all precipitation, and my region would be my region of interest, and the reducer here is ee dot reducer dot mean, and the scale we have seen already 5566 meters, and the x property we do not have to specify. By default it will be our date range. So you just close it and print the chart. So you got an error. So here you find we have mistaken for the system start date. So it should be system time start, and it should be system time end. Now give it a run. So you just imagine the speciality of Earth Engine. So you don't have to again go from starting and end. You just manipulate one thing, everything will be run automatically. So now if you can see, we have the rainfall from 1981 to 2020 for the past 20 years. So in just one click. So you have the band mean, it means the precipitation in millimeters. So as you can see, the highest rainfall is seen in 2005 for my region. So if you can check out, so for the Shimoga region in the Karnataka, the highest rainfall was occurred in 2005. It was 981 mm of rainfall for the entire year. So here it is little more in the 2010. So as you can see, we had a drought since the 2019 or 2018. So there the rainfall is quite less. So like this you can plot for the entire year. You can create a function, and you can do for 1 year how does it look, and you can return the same for every year if you want, if you have the function. So now I want to manipulate and create a trend line for my region of interest, how the precipitation has changed. So now I want to customize. So I'm creating a options. So we are using the function dot set options. So we need to specify the options, like what should be on the title. So I want my title to be precipitation in precipitation from 1981 to 2020 for the Shimoga. And I want my horizontal axis to be modified. So I want the title to be years, and I want the format to be in the year. That's it. And on the horizontal axis we have done. So we need to do on the vertical axis. So just specify vertical axis. So I want my then title to be changed from the band mean to precipitation. And it's helpful if you do in and format, let's just be that. So again I want my trend line to be set. So before going to trend line, you just click on the run and see if it works. So you can see my precipitation has been renamed to precipitation We have the legend with the precipitation showing in the blue bar, and we have the years at every 10 years interval. So now I want my points to be in here. So we can specify point size to be 2. Give it a run. You'll get your points at each year. You see 1986, 1988. So wherever there is a point, we have one reading there. So now I want to set my trend line. So the argument for it, we should specify the type. Let's say I want this type to be linear. So let's have a linear trend line. But I should also specify my series. So for which band I have to draw the linear. If you have multiple bands, so it's asking for which band or the series I want to draw the trend line that is linear. So now if you find, we have a trend line for our data set. So here you can find our data set has the trend line, so it has points, it has the line width. We can change the color if you want. So anywhere you just hover it, you'll get you should get a equation around it. Yeah, in here you will get the equation, a linear regression equation for the precipitation with the time start and end for the date. So now I want to have, now I want to manipulate my trend line. So I want to have color to be black, and I don't want any of the point size. Give it a run. Yeah, here you will see a change has been occurred to 0. So my point size I want it to be 0. The color has been changed to black. So now we get a linear line showing the linear regression. So for the precipitation data set for the past 10 years. So if you want to change your trend line from linear to let's say, so for the precipitation data sets, the linear is good. So you can also have the exponential trend line, or you can also have the polynomial trend line if you want. So it doesn't really suit well. I'm just showing in here in order to see if it does work or not. So I have given polynomial. So let's see if the trend line changes. So here you see our trend line has changed from linear to polynomial. So you can also have exponential in the place of it. Yeah, again it's changed. So you can see the difference between the linear, exponential, as well as the polynomial trend lines. So like this, if you can do for your own city, then you can do it. So here if you can just expand it, you can see the x ticks. It's showing everywhere at a 200-year interval. So what if I want to show only 2 or 3? I want to show at 0, I want to show at 500, 1000, and 2000. So we have more than 2000. Okay, we'll plot up to 2500, but I want only 4 ticks on my y-axis. So how can I control that? So for that, we can do, we can add and format here. So we have the vertical axis. So you just specify one parameter called y-ticks. It's just a ticks. So you give a list. I wanted 0, I wanted 500, I wanted 1000, I wanted 2000, and a 2500. So give it a comma. Let's run. So it should not be is equal to, it should be a colon. Yeah, you see we have at 0, 500, 2000, and 2500. I think I forgot to give 1000. We have given 100, so 1000. Yeah, here you find 0, 500, 1000, 2000, 2500. If you want, you can add 1500 in between. Give it a run. Yeah, now it looks somewhat better. So like this, if you can do and download your CSV, SVG or PNG, so it will get automatically downloaded, and you can just open it and publish it in wherever you want. So it's quite not a good quality. Yeah, like this you can do. So I hope guys you have enjoyed how you can create a trend line in Google Charts, and how you can manipulate and hover around it in order to get the equation, linear equation, or the exponential or the polynomial equation for your own data set. So thank you for watching. So you can post any comment, you can post any doubts if you have in the comment section. Thank you.